In this section, I'm going to teach you how to finish off the last step of the reduction method, which is solving your last 4 centers. At the end of your first 8 edges, you should have 4 solved edges on the top and 4 on the other layer. So your last 4 centers should all lie in this equator slice. Once again, to solve our last 4 edges, we are going to be using the same concepts as 4x4 because we need to solve these edges without disrupting any of the edges on the top or the bottom. So the idea is we keep them in the same plane, slice, flip this edge and slice back to finish off the pair. Once again, even though conceptually it's similar, 5x5 has a big fundamental difference in that you're not making edge pairs, you're making edge triads. So I'll show you how to go about it. The first thing you want to do is to pick a wing and its corresponding midge, and you want to solve these two together. If they have the same color facing you, you cannot slice and pair them up, as you can see. So the first thing you want to do is to flip either of these. I'm going to flip the midge. Now I'm going to slice this over to pair these up. But as you can see, that disrupts our centers. So now I'm going to flip this so that this wing moves to the bottom and the top slice is empty. And now I'm going to slice back and we have this built. And now I'm going to show you how to solve the last wing. So the last wing is over here. First off, you don't want the wing to be over here because while you can slice to pair it up, you have nowhere to insert the edge so that you can restore your centers. So you want the wing to be not in the empty slot slice, but in the other slice. So we flip it, and now also you can't slice the wing over like so, because as you can see, this wing does not actually belong here. That's why it is flipped. What you want to do instead is move this empty slot over to here by slicing. Then you can flip this edge and move this wing to the top. And finally, when you restore your centers, you have an edge triad completed. Now let's discuss some special cases. The first is one that we have already encountered in our first 8 edges, where you have a midge and a wing connected, but the wing is flipped. Like I've mentioned in the previous section, this is because this wing actually belongs over here. So we find the other wing, which is over here. This time you want to slice and displace this wing, like so. Then you want to flip this edge so the empty slot is in the bottom. So now when you slice back, you've finished off this triad. Next, let's take a look at this case where you have 2 wings solved and the midge is missing. In this case, the midge is over here. There are a couple of things you can do. The first thing is, if you want to pair it up normally, again you need to make sure that different colors are facing the front. So let's flip these wings. And now you can solve this like you normally would. Ignore this wing for now and just solve this wing with this midge. You slice it over, flip this edge, and then slice back. And now you have a familiar case. You just slice this empty slot over, flip this edge to move the wing to the top, and slice back, and you're done. However, here's a pretty cool solution that you can do instead if you'd like. For this, you want to ensure that the colors on the front are the same. Now you want to move the cube sideways like this, so that the wings are on the bottom and the midge is on the top. Also, this will only work if this edge is unsolved, which it is in this case. So you want to slice this middle layer up like so to a U2 which doesn't affect the centers because this is a symmetric case, and then slice back down. And then rotate back, and you fully solve this edge very quickly. So, of course, once you're done with one edge, you move on to solving another edge. Here, I'm going to solve the yellow-blue. As you can see, there are different colors in the front, so I can slice to pair them up, flip this edge, and then slice back. And then the last yellow-blue is over here. Again, I can't simply slice to pair it up because now I have no place to insert this edge, so I can slice back. So I'm going to flip this edge and put this on the top. Now I'm going to move this empty slot over to here, flip this edge, and then restore. And then we are left with our last two edges. The first thing I want you to do is to move them adjacent to each other. So if they're in diagonally opposite slots, just do an R2 to bring them both to the front. This works because you're not disrupting any of the solved edges. You're simply swapping this solved edge with this solved edge and putting this solved edge in the back, as you can see. Now, for your last two edges, you might actually need a couple of algorithms, which I'm about to show you. The first algorithm is for this case. As you can see, both the edges have a midge connected to the wing, and the last two wings need to swap. There is nothing you can do in this case to solve it without an algorithm, because you can slice this over, but you have nowhere to insert this, or you can slice this over and you have nowhere to insert it. So the first thing to make sure is that both of these wings are in the same slice. If they are in different slices like this, flip either one of these edges to make sure they are in the same slice, like so. Now, you want to hold the cube like this. You want both of the wings to be on the left, and you want one edge in the top front spot and one in the top back spot. And now you want to do this algorithm to swap these two. And that swaps these two. And the second case you can run into is this one. There's only one edge left to solve, and as you can see, it forms a kind of checkerboard pattern. That's because this wing belongs here and this wing belongs here. Once again, you can't use the aid of any empty slots over here because there are none. So what you want to do is hold the edge in the top front spot like this and perform this algorithm to swap these wings. You will notice that this is very similar to the 4x4 OLL parity algorithm with a slight modification. And as you can see, that swaps these two wings without disturbing any other edges on the cube. It's important to note that you're not always going to need an algorithm for your last two edges. For example, this is a case that can actually be solved without any algorithms. The idea is you want to solve one out of your last two edges. In that case, either the other edge is going to be solved, or you will run into one of the two cases for which I have taught you an algorithm. For example, here, let's pick one of these two edges to solve. I'm going to choose to solve the green-orange edge. So, we need this to be in the bottom slice because we can't simply slice this over to pair it up because there's nowhere to insert it. So, let's first flip this edge. Now, let's slice this over to here, flip this edge to bring this into this slice, and then slice back. As you can see, that completes both of our last two edges and in this case, we did not require any algorithm. Here's another case which will not require any algorithms. Once again, over here, the idea is we're going to first try and solve either one of these edges. In this case, I'm going to try and solve the orange and green edge. So this is a case where we have two wings solved and the midge needs to be solved. So first we make sure that a different color is in the front. In this case, it's the same color, so let's flip the midge. Now let's solve one of the wings with the midge. We slice this over, flip this edge, and slice back. And now let's solve the other wing. It's already in the correct spot, so we move this empty slot over to here, flip this edge to bring this wing to the top, and then slice back. And as you can see, we were able to solve our last two edges without any algorithms. Now, I would like to show you a case where you will require an algorithm to solve your last two edges. This might seem very similar to the previous case. As you can see, these two midges need to swap. So, again, let's try and solve either one of these edges. In this case, I'll try and solve the red-blue edge. First, I'm going to solve this wing with this midge. I'm going to slice over to pair it up, flip this edge to move the empty slot to the top, and slice back. And now, as you can see, we have reduced it to the case where we just need to swap two wings. This case will require an algorithm, so you flip this edge, set up for the algorithm, and then just execute it. And you're done.